Welcome. Let's continue. Episode number 17, still on statistics, static mechanics. In this episode, we want to deal with resultant of what? Forces. We've learned in the previous episode how we can resolve forces from the magnitude bearing form to vector column form and vice versa. So here, under the resultant of forces, we are going to pick it from those who have two concurrent forces and the coplanar forces. So the first one is resultant of two concurrent what? Forces. Forces that are acting from the same point. That's the concurrent forces. So if two concurrent forces F1 and F2 act at a point O, and the angle between them is theta, we can find their resultant forces using the parallelogram law of what? Vector addition. So let's make a sketch of that. Can I manage this piece? Let's see if we can manage. Here we have the first force. Let's take it from here. So if the first force is here, and the second force also move in this direction. So the two forces are acting from the same point, that is the O. So I have my first force as force 1, then I have my second force as what? Force 2. So these are the two forces that are acting from a particular point. To find their resultant vector force, we need to find the resultant from this direction. But remember, we are told the angle between them is what? Theta. The angle that the two lines form is theta. Now, if we want to take a parallelogram law, we can extend this line, which will be parallel to the one we have as force 1, and extend this as well, which is also parallel to the force 2. We can see that the resultant vector is going to be, let's put it here. So this is going to be the resultant what? Vector. Remember, in the addition of vectors, we move from here to here is the same as moving from here to that place. I guess that is what makes the parallelogram. A vector addition. We are moving from here. So this is the direction. We come here. It's the same as from here to here. So this is a resultant vector, if I will use the word vector. Resultant vector. If I am just to move from here to here, the result is to move in the quicker direction to this place. Alright. Now, what do we have? We can see that the resultant vector divide the angle theta we have into two, not equal part, but it divided into two parts. So we can label the down angle also as what? The alpha. Now, this line is parallel to this. So the angle here is co-interior to the theta. Remember, co-interior angles are angle found on the same side of a transverse and a parallel line. So this is the parallel line. This line becomes the transverse. So this right here will be 180 minus what? Theta. Because this plus this will give us 180 co-interior angles. Alright, if that is out of the way, then it means that in order to find this place is also going to be force 2. This will also be force 1 if we are to understand parallelogram. Opposite sides are being what? Equal. So let's say applying. So now if we are going to apply the cosine rule in order to find the resultant force here, we have labeled here as A, B, C. So we are having triangle O, A, B. We are picking this, which is going to be almost the same as the one at the other side. What does the cosine rule state? We are looking for the longer side or the side facing the angle, which we are looking for as R squared equals to F1 squared plus F2 squared minus 2F1 F2 cos the angle, which is 180 minus what? Theta. If you check the playlist, we have derived the formula for the cosine rule, how it become this way. This is C equals to A squared plus B squared minus 2AB cos the angle C. So the angle facing the R is what we are having here. Now, but if you look at this carefully, this is also a compound angle under trigonometry. So if I have cos 180 minus an angle, the result is just negative of the cos of that angle, which means this. So I can just say that, but cos 180 minus theta equals to negative cos what? Theta. If you do the compound angle expansion of cos 180 minus that, which is going to be the cos 180 cos theta plus sine 180 sine theta, and sine 180 is 0, so the second part is gone. Then cos 180 is also negative 1. That gives you your value in there. So that means that I am going to put negative cos theta here, which these are all multiplying. So the negative will come here and multiply. That will make your r squared equals to cos 1 squared cos 2 squared plus 2 cos 1 cos 2 cos what? Theta. So this is what I'm going to use if I want to find the resultant vector of two concurrent forces which are acting from the same point. If they are from the same point, I'll be using the cosine rule. Alright, I can also be asked to find the angle, the direction of what? The resultant force. What is the direction? The direction, or is the angle it formed with the first force. The angle that the resultant force is forming with what? The first force. So you can see this is facing here, this is facing here, as we did for cosine. If I am looking for this, I can also use what they call the sine rule. So let's see. Let me just put this here as my first, so that so applying the sine rule to the triangle OAB. We know that I can pick this which is facing here as the angle. I can pick this facing here. I don't know the angle here, even though after knowing this I can find it, but that is not our concern now. So I am going to have the force 2 divided by the sine of the angle alpha equals to the resultant force over the sine 180 minus what? Theta. This angle is facing here. So this over this as the sine rule. But remember, we've derived this in some episode under trigonometry. Check that on the YouTube. Here, based on compound angle, if you have a negative of this, if you find the expansion, you get a positive sign. So this will just be r over the sine what? Theta. Very simple as that. So if I am putting this and this together, looking out for this, it means this is multiplying this is multiplying this. So that means your sine alpha equals to this times that, cos 2 sine theta divided by, as this multiply this, you divide it by what? That. So that gives us the second formula. This is used only if you are asked to find the direction of the force, the resultant force. If that is not asked, we don't need this one. But if you are asked to find the resultant, then this will be applied. In some cases, the resultant will be given to you with one of the forces. So if I've been given this and this is being given, I can find this by what? Doing change of subject. All right. I guess the concept envelope into this is understood. We can understand this perfectly if we take an example to buttress the point. All right. So this is the question. two forces of magnitude 10 Newton and 12 Newton act on a particle. If the angle between them is 60 degrees, we have to find the magnitude. That is a resultant, okay, the magnitude and their direction of the resultant force. So we need the resultant force, we also need what? The magnitude. Now, with what we did in the previous just ended part. Now, if the angle between the two forces, let's say this and this, the angle between force 1 and force 2 is 90 degrees. That means that the resultant is passing here, force 2 is here, which is also perpendicular. So I will not be able to find the resultant vector using the sine rule. Even if I use it, the second part is going to be 0. So you can see this is a right angle triangle. So I use Pythagoras theorem as resultant square equals to force 1 square plus what? Force 2 square. You see, this is what I will use in finding the resultant forces. If the angle between the two forces that are concurrent from a point is 90 degrees. I guess that is clear. I want to let this out before we continue. All right, so let's make a sketch. Can I borrow the space here? All right, so if we draw this just like we did from the introduction, this is our resultant vector. Remember, this is 120 because 180 minus 60. The angle here, you can use alpha and beta. In the previous one, we have two angles to represent. Here we have only one angle which is unknown to represent, so I can use theta. Now, what do? I need this. So I am only going to apply. So when we apply the cosine rule to the triangle OAB, we can see our resultant vector force, will be equals to the force 1 square, force 2 square minus 2 force 1, force 2 cos 180 minus what? Theta. And 180 minus theta is giving us what? 120. Remember what it means? It means that your r square equals to, okay, let me still maintain 10 square, 12 square. This become plus 210, 12 cos what? 60 degrees. We move away from the 120 and come to 60. Remember the formula very well. Not to get confused with that. We can use the 120 in it directly, which will have effect on this. If you don't want to work with the negative, this is what we can have. So our r square will be 100 plus 144. This is going to be 120 times this, 240. Then cos 60, we have 0, 30, 45, 60. Cos will be 1 over 2. So this is going to be 1 over 2. This is going to be 244 plus 120. So let's see, if we add this, 364. So r square equals to 364. Your r will be the root of 364. What would that be? I think 380 something. Okay, that would be 19, I guess. Let's see. And that will give us 19.08. This is a force, so we have what? Newton. Remember, this is just the force of the magnitude we are having here. We need to also know the direction, so we need to apply. So applying the sine rule, remember, this over the sine of this over the sine of this. So we can have 12 divided by the sine of the theta equals to resultant, which we know as 19.08 divided by the sine of what? 60. This is what we have. 180 minus 60 becomes sine 60 alone without the 120. Let's take cognizance of how we are changing the angle with the angle between the two forces. This is going to be 60 degrees. So from here, we should have our sine of theta equals to 12 times sine 60 degree divided by 19.08. And if you put that in your calculator, you should be having 0.5447 to 4 decimal places. But you need theta. So theta equals to the sine inverse of 0.5447. And that will give you 33.004. So let's go to the nearest word, degree. All right, so the conclusion we can make from here is that the resultant force, the force R, which is 19.08 Newton, is acting at an angle of what? 33 degrees with the force of magnitude 10 Newton. Remember, this is how the diagram was. So this is the resultant 19.08. This is the angle 33. This is the force 10 Newton. So the resultant is making an angle of what? 33 with the magnitude of the force 10 Newton. But we need to know the bearing of the magnitude itself. The bearing of what? The resultant force itself, which normally is measured from where? From the north. So we are looking out for from here all the way to where the resultant force is. And that is going to be, it's supposed to be 90 to this place, but from here to here is from, if you take away 33 from 90, you should be left with the back there. And that is what is giving us what? 57 degrees. So this is going to be the representation of the resultant what? Force, the magnitude and the direction. This is just to show that the magnitude of 19.08 is making an angle of 33 with one of the force. But the angle itself that it makes by reading from north will be 53 degrees. I guess the concept is clear. Alright. Then if this is clear, we will be taking more examples in the subsequent episode. Don't forget to come back and learn before us. We take this series to the next level. Subscribe if you have not, share with somebody, like the video after watching, and leave a comment.